Good morning, everybody. So today we're gonna explore more with algebraic expressions, but more importantly, we're gonna make this connection to equations like we were working with towards the end of last unit, or actually a lot of last unit. Okay. So before I get started, again, just let me remind you if you haven't turned in both parts of the test, both parts, so the Google form and the short answer. I have a lot of people that just turned in the Google form. I need both. Okay, they both together make up your grade. So if you haven't sent in both, I need those as soon as possible. Okay. The retake this week, that'll be on Wednesday. Gonna give you, you're gonna have a lot of time to do it. So you can kind of, if you need some extra study time, you can do that. Make sure you are keeping up on the work we're doing right now, though. Alright, so without further ado, let me get started. You might be looking at the screen thinking this looks a lot like yesterday's video. And that's because it's from it, and we're going to build on to this now because yesterday, as I said, kind of had the 6th and 7th grade together. Well, today, we're going to focus on this. We're going to take this a little bit further than the 6th grade. So, just let me remind you, or if you didn't watch yesterday's video, which you should watch it before this, um, we talked about yesterday where we had a situation where Judy was maybe saving up for something. She's trying to figure out how much money she has altogether. So Judy right now just has $2 in her pocket. But she has this piggy bank that she's been putting in her, putting her allowance in for, maybe a long time. We don't really know. Okay. So we said yesterday that we could write an expression, which is like part of an equation, kind of like half of it. And we said that we can represent how much money Judy has altogether by this expression here. Okay, so she had $5 in her piggy bank. Well, we said we could just plug in 5 for x, and that would tell us that she has $2 in her pocket plus $5 in her piggy bank. So she'd have $7 altogether. Right? She'd have $7 total. But if she had $100 in her piggy bank, we said that we could add up the $2 in her pocket plus that $100, and that would tell us that we had $102 in all. So we don't know how much is in the piggy bank, but if we did know, we could use this expression to find out how much money Judy has altogether. So let's take this a little further. Okay? An expression, it's representing how much money she has altogether. So let's introduce a new variable, one that you guys have worked with, and honestly, you guys really impressed me with it. But we're gonna use y now instead. We're gonna turn this expression, this 2 plus x here that we started with, and we turned it into an equation because we said this expression here is telling us how much money Judy has altogether. So we'll say how much money Judy has altogether is y. Okay. So let me zoom in a little here. Okay, so she's taking the money in her pocket plus the money in the piggy bank. We're calling the money in the piggy bank x. And however much money she has total now will be y. Now let's take a look at this equation a little bit. So we're starting off with 2 plus x, and we said that's equal to y. So this might look a little different. We've worked with slope-intercept form a little bit, but the equations are usually written a little differently than this. So there's some things I just want to make clear because in algebra, there's going to be some rules that you need to know, and the better you know them, the easier everything's going to be. Okay? Just one of those things. If you know the rules, the rules of how to work with variables, it's going to make everything easier for the rest of math. Okay? Because algebra is what we've been building up towards, what you've been building up towards your whole life. Okay? It's the next step in math. It's everything you're using, you've learned. We're going to apply it to algebra. Right? Not necessarily all in 7th or even 8th grade. Right? It's something that takes years to do. Right? You'll do algebra all throughout high school, but it is something that we're getting a great start on here. So, anyways, we have 2 plus x is equal to y. Now, we have an equal sign. That means 2 plus x is the same exact thing as whatever y is. Right? 2 plus x is some number, y is some number. And we know that they're the same because we have an equal sign. That means that we can switch these around. Actually, let me show you. So we have 2 plus x, and we know that's the same thing as y. So we can switch the y and the 2 plus x. So we can put the y over here if we want to, and the 2 plus x. So I'm going to do that, and I'll show you why in a second. Because now we have y is equal to 2 plus x. But remember, when you add things up, the order doesn't matter. Okay? This is actually called the commutative property of addition. Don't worry too much about knowing that right now, but if you can remember it, that's good. It's called the commutative property of addition. It means that you can add up numbers in any order. So 2 plus 3 is 5. 3 plus 2 is 5. Didn't matter that I switched 2 plus 3 around. So it doesn't matter with variables either. Right? A variable is just a number. It follows the same rules as these. So that means 2 plus x is the same thing as x plus 2. Now, this here, this is now in slope-intercept form, which we talked about at the end of the last unit. Right, we have our x, and then we have plus a number. Okay, so let's line this up and let's figure out what's what here. We said we can find the slope, the y-intercept. Let's do that just so we can understand this problem a little better. So, again, we have y is equal to x plus 2. Well, let me kind of line that up with our y equals mx plus b, our slope-intercept form. Let's line these all up. So we have y equals x plus 2 right here. That's what I wrote here. So we don't see a number written in front of this x. Whenever you don't see a number there, that means that there's actually a 1. Okay? Because if you multiply any number by 1, you just get the same thing back. Right? 2 times 1 gives you 2. 3 times 1, 3. 4 times 1, 4. So x times 1, x. And it doesn't matter the order you do it, because multiplication is also commutative. So that means that you can multiply things in any order. 1 times 2 is the same thing as 2 times 1. And then we know 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4. So 1 times x is x. And these are the same thing here. And x times 1 is the same thing as 1 times x. They're both equal to x. So this equation that we wrote up here, y is equal to x plus 2, we wrote this as y is equal to 1x plus 2. Now we said that this number in front of the x here, this m, we said is our slope. So that means that this 1 is our slope. And then we said that whatever number comes right here is our y-intercept. Right? That's our b, our y-intercept. So our slope is equal to 1, our y-intercept is equal to 2. So we'll keep that in mind. zoom out a little. So we're going to work on now graphing this equation. So, excuse me. First, let's set up our xy axis. So remember, we put our x horizontally, left to right. We said x is how much money was in the piggy bank, plus the $2 in her pocket. And then we said y is how much money Judy has altogether. So if you wanted to graph this, you can fill out a table of values. This is not something you need me to tell you to do or IXL. If you want to make a graph, you make your own table. So, and you can just plug in some numbers that you see would be on the coordinate plane. So let's see, when x is 0, that means that if there's no money in the piggy bank, well, that means that Judy just has $2, right? If there's no money in the piggy bank, then she has just the $2 in her pocket. If there's $1 in the piggy bank, well, there's 1 plus the $2 in her pocket, $3 altogether. $2 in the piggy bank, well, $2 plus the $2 in her pocket, that gives you $4 altogether. So you can see, basically what we're doing is each time you're just adding $1 to that piggy bank. So however much money she has altogether goes up by 1. But what if, sorry about that. I want to get everything on the screen here, actually. Alright, sorry about that. So, anyways. What's going on here is, well, we're just adding 1 to x each time, so we know we add 1 to y each time. Right? Because we know that's going to be the same thing as our slope. Right? Whatever we're adding each time, this is your slope over here. But that's only the case if you're adding 1 to x each time. Okay, so you do need to be careful about this. What if it kind of skips around a little bit? Or doesn't count by ones? Well, then we need to be careful because now it's not going to be plus 1 here. Right? We did plus 7 here. We said for every time we add 1 to x, we add 1 to y. So that means we're also going to add plus 7 over here from 5 to 12. Okay? Or if you get from 10 to 100, you could do the same type of thing, right? We said from 10 to 100, that'd be plus 90. Well, you add 90 here, and you get 102. Okay? So now, what about this last row here? Notice this one's a little bit different. This x is missing. And maybe you have an idea of how to figure that out. Let you kind of keep that in the back of your mind. It's not going to be something we necessarily talk about today, but it's something I do want you to think about because it's something we're going to use next week, something we're going to explore, at least by the end of the week. Okay? So I want you to think if you can figure out an answer for it. If you can, it's okay, but if you can, think about what steps you took to do it. Now, what I wrote about down here, I'll let you kind of read through that. I'm going to post the notes as well, but I want to make sure we keep getting through this because I'm going to be posting 2 videos today. One for this one to kind of go through a little deeper, a little bit of a talk, and then I'm going to post a shorter video to show you how to do the Excel. Just a few examples. So, anyways, let's keep going. This is the last bit I got here I want to talk about. Let me copy this. Alright, so I took this table, the coordinates, I put them over here, and what I did is I actually went ahead and graphed them. It's a little small, I'm sorry. Let's see if I can zoom it a little. Okay. It's a little blurry, but I'll read what I wrote. Alright, so all I did is I went ahead and I plotted these coordinates here. Couldn't fit these two, um, but I got the others on there. So 0, 2. Remember this, when x is 0, that means it's on the y-axis. So that means that this first point on the y-axis is our y-intercept. Just like this 2 here. Oh, you have a 2, you have a 1, and then we have a 2 right here. So you can see the y-intercept is 2, just like we have in our equation. Okay? And that point on the graph is 0, 2. Now, notice that every time we add $1 to the piggy bank, or there's $1 extra saved in the piggy bank, that means that Judy has $1 extra. Right? So we set our slope in this case for this equation. Right? So that was 1, right? We have that 1 in front of the x. So that's what you see here. We're adding 1 each time. So that's the slope of our equation. That's how it's changing. It's the rate of change for this equation. Okay, so the slope is how y changes. Whenever your slope is when you add 1 to x, that's what I kind of have written here, but it's actually really nice to see it. So if we add 1 to x, oops, sorry, that's off the screen. Let me write it a little bit down here. Or I'll just read it. I have it on the page. I am going to post these notes. So I do want you to really think about this line here when I post the notes. Every time we're adding 1 to x, so we add 1 to x here, well, we're adding whatever the slope is to y. So in this case, the slope's just 1, so we add 1 to x, we add 1 to y. Add 1 to x, add 1 to y. But what if the slope was 3? What if the slope was 3? Well, that would mean that you would, every time we add 1 to x, we'd add 3 to y. So you'd get a graph that would look something like this. Okay? So it'd be a little bit steeper. A steeper mountain versus a hill. Okay? And that's because this is a greater slope, greater incline. And that's something we'll have to keep in mind. But there was also one last question I asked you to kind of keep in the back of your mind. How could we find x here? And what I'll talk about is maybe what you did to solve this. Okay, you said, okay, well, y is 200, so x is going to be, well, we know we're adding 2 to whatever x is, so x would have to be 198, because 198 plus 2 is 200. Right? If we said x was 198 plus the 2, it'd be equal to the 200 that we want here. But that's, what if it was a little trickier? What if we were working with decimals or something like that? This might be harder to do in your head. So what we're going to talk about next week are certain steps we can take to solve for x in these type of equations. And what you're going to see is if you set up something like this, 200, right, 200 for y, so we plugged in 200 for y, and then we said x plus 2, you're going to see that instead we can subtract 2 from both sides, subtract 2 from over here, and this tells us that x is equal to 198. So that's something we'll talk more about next week. You're going to see that there's certain steps that we take when we see an equation like this, and then other steps we take when we see like a proportional equation, like y is equal to um, k times x or mx. So we'll talk more about these. These type of equations here, these are called one-step equations. And 6th grade is going to be doing one-step equations, but we're going to be adding a little bit more to it, because we're not just solving one-step equations for the fun of it. We're trying to find out what that missing x is, like we have here. So I want you to keep thinking about that. Um, the other video I'm posting is going to have direct help on the IXL. This is just kind of a talk, a little bit of an overview of what we're going to be doing and how we're going to be approaching this unit. So that's all I have. Please take care.